All right, hey guys, taking a look here at 10.5, solving quadratics by completing the square. So hopefully you've already done the assignment of doing this with algebra tiles. If not, I would stop right now and go back and do that one first. I think that's really going to help you make more sense of what we're going to get, what we're going to do here. All right, but we're looking at solving quadratics, and right now we've got two different ways to solve these quadratics. We can solve a quadratic, and again, remember, a quadratic is just something involving an x squared. So we can solve these quadratics by factoring and using the zero product property, or we saw that we can also factor these things by graphing, by looking at the graph and where are the x-intercepts. What we're going to look at today is just a third way to solve these things, solving them by completing the square, something that you guys kind of started, hopefully, if you did that algebra tiles assignment or activity. So let's just look at factoring these. Take a look at what's going on here. So again, looking for factors of 9 that add up to 6. Let's see, I think that's 3 and 3. So I can factor this as x plus 3 times x plus 3. All right, or we can write this as x plus 3 squared. All right, kind of a quicker way to write it. Here I'm looking for factors of 16 that add up to -8. That would be -4 and -4. So I can write this as x minus 4 times x minus 4, or a little quicker way to write it is x minus 4 squared. Just a little bit of review as we go through here. Now, we see that these are both perfect square trinomials. All right, the factors of 9 that add up to 6 just happen to be the same thing. The factors of 16 that add up to -8 just happen to be the same thing. And that's that idea of completing the square. So here it says find the value of c that makes each expression a perfect square. All right, and this, I think, this is why I had you do that algebra tile thing. So what number do I need to put in for c in order to be a perfect square here? Well, hopefully you saw from that algebra tile thing that if I take half of this, which is 6, and square it, I get 36. All right, and x squared plus 12x plus 36, all right, can be factored. Factors of 36 that add up to 12 are 6 and 6, so I can factor this as x plus 6 squared. All right, I took this expression and I made it into a perfect square. All right, the algebra tile thing kind of showed you how to do that with pictures. Now we're looking kind of at the algebra behind it. So now let's take a look here. Well, what number do I need to put in for c? Well, again, I take half of -10, that's -5, and I square it, or take it times itself, and that's 25. All right, so x squared minus 10x plus 25. All right, and now I can factor it. A factor of 25 that adds up to -10 would be -5 and 5, so I can factor that as x minus 5 squared. And then we see here, we can even do it even if the numbers aren't pretty. All right, so what would I need to put in here for c in order to make this a perfect square? Well, just like I did here, just like I did on these top two examples, I take half of 3. Half of 3 is 1.5, and 1.5 squared. Let me take a look at that. I'm pretty sure I know what it is. I know what it is. I'm just making sure my calculator works. It's 2.25. All right. So x squared plus 3x plus 2.25. We can even do this with decimals. And now factors of 2.25 that add up to 3. Now that's that x plus 1.5 squared. And hopefully you see that this number is always just half of that. It's that halfway point before we squared it. Okay. That number is just half of that. That number is just half of that. All right, so part of your homework tonight is taking an expression that's not quite a perfect square yet, and just like you did on that on the algebra tile activity, figuring out what c needs to be in order to make it a perfect square. All right. So what? All right. Now, so we can make things a perfect square. Well, how does that help us solve these things? Let's take a look at 3 examples here, and then we'll go from here. Now, this first example, I look on the left-hand side, okay, and this is a perfect square. All right. The factors of 64 that add up to -16 are -8 and -8. So I'm going to write this as x minus 8 squared. I've factored that left-hand side. Now, it still equals 49. Now, in the past, just let me pause here real quick and talk about this. In the past, we would get this equal to 0, all right, and then look to see if we can factor it from there. solving by completing the square is just a little bit different. We're not necessarily trying to get it to 0. Again, I'm not trying to confuse you with all these different processes or these different ways to solve a quadratic. I'm just trying to give you as many methods as possible, and then you can solve it how you want. But now here's what we do. All right, we can now solve this thing just like we have been with solving it, by doing a square root. All right, now that I've got a square, I can undo that square as long as I do it to both sides. The square root of x minus 8 squared is just x minus 8. And now remember, the square root of 49, when we're talking about solving an equation, we have to look, that could be 7, or x minus 8 could be negative 7. All right. When I solve an equation by taking the square root of both sides, I have to look at both that positive square root and that negative square root. All right. And now I can add 8 and add 8, and I get x equals 15. All right. Or I add 8 and add 8, and I get x equals 1. I get 2 possible solutions here. All right, just like I normally would. And this is the same thing we would have gotten if we would have subtracted 49 and factored it the old-fashioned way by using the zero product property. Still would have gotten these two answers. If you would have gotten this equal to 0 and then graphed it and looked for the x-intercepts, guess where they would have been? All right, this is just another way to do this. All right, so this one was already a perfect square. What if it's not? All right, let me get my little division line down here. All right. So this isn't a perfect square. Well, we just saw on the front, we can make this a perfect square. All right. So if I take half of this, half of negative 2, which is negative 1, and square it, negative 1 squared is 1. All right. So I can, x squared minus 2x, I can add 1 to that side, and I now know this is a perfect square. And that's okay as long as I add 1 to that side. All right. So this idea of completing the square, again, all I did is exactly what we did here, all right, by finding that value of c. It just, now since we're talking about an equation, I have to make sure I do it on both sides. So now this can be factored. X squared minus 2x plus 1, factors of 1 that add up to negative 2 is negative 1 and negative 1. So I can write that as x minus 1 squared equals 4. Now that I've got a square, I can solve this by taking the square root. And the square root of x minus 1 squared is x minus 1, and that could be 2. Or x minus 1 could be negative 2. And now I just solve both of these equations. I add 1 and add 1, I get x equals 3. Add 1 and add 1, I get x equals negative 1. So 2 solutions. All right, and then finally one last example. All right, this is not a perfect square, but we can make it a perfect square. Here we go. Take 10, take half of it, that's 5, and square it. I want to add 25 to that side because now I know this is a perfect square, and that's perfectly okay as long as I add 25 to the other side. Okay, so now I can factor this, factors of 25 that add up to 10 or 5 and 5. So I can write that as m plus 5 squared. And now here, negative 8 plus 25 is 17. And now I can take the square root of both sides. The square root of m plus 5 squared is m plus 5. Now, the square root of 17, I don't know what that is. That's ugly here, right? Okay, so let's see what that is. If I find the square root of 17, actually, I'm going to do this. I'm just going to leave it the square root of 17 for right now, okay? Or I know that I'm also going to get the negative or the opposite of the square root of 17. And so now I still want to get m by itself, so I subtract 5 and subtract 5, all right? So here I'm going to get m equals the square root of 17 minus 5. And now here, this I can't combine these. This isn't the square root of 12, all right? So again, on your calculator, yours is going to look a little bit different. But I just want to find the square root of 17, all right? That's that big, bad, ugly number. And then I want to take away 5 from that. All right, and I'm going to round to the nearest hundredth, so let's say negative 0.88. All right, so one of my answers is m is approximately negative 0 and 88 hundredths. And now the other one is subtract 5 and subtract 5. Okay. So now this one's going to be a little bit trickier here. On your calculator, go ahead and I'm going to find the square root of 17. Okay, you'll get that answer again, but now you want to put a negative sign in front of it. If you just hit the negative button on your calculator, it'll automatically put that negative sign in front of it. Okay, I need to hit negative and then say, hey, take my last answer and put a negative sign in front of it. And now I want to take away 5 from that. And I get negative 9.12. All right, so M could also be approximately negative 9.12. So again, two different solutions. And this last problem kind of points out, hey, why do we have to have all these different ways? As soon as I see these ugly numbers, this is one I could not have factored. There would have been no way for me to factor this thing. If I get it equal to 0 by adding 8 to both sides, I can't find any factors of 8 that add up to 10. So we need to have these other methods because we're going to come across quadratics where factoring isn't an option. Or maybe you don't have a graphing calculator handy and you can't just look at the x-intercepts. All right. So this idea of completing the square. All right. Make that thing on the left a perfect square. Take half of b and square it, and that's what you add to both sides. This thing can now be factored as a perfect square. We can use our square root. Don't forget the negative square root when you do that, because that's what's going to give you your two answers. All right. Take a look at these problems in your book. I will be posting the answers here shortly and put those up on Flipgrid. If you have any questions on these, most of you have been doing a really nice job with this. If you have any questions on these or any that you don't understand, please don't hesitate to contact me. All right. Okay. Take care, guys.